This is an interview with Adam Grzywaczewski, deep learning architect at Nvidia for over 6 years. Before Nvidia, Adam did a Ph.D. in information retrieval systems, which ended in 2013, and then worked as a research engineer at Jaguar Land Rover. This interview is the third and last interview in partnership with Nvidia and the GTC event. Here's your last chance to win an RTX 4080. You just have to attend the free GTC event, take a screenshot and send it to me. You will see that there are a lot of incredibly interesting talks, including the ones that we'll discuss in this interview. I hope you enjoy it. If you could go over your background, I've seen that you've done
Sure.
a PhD and worked as a research scientist and now at Nvidia. So I would love if you could go back a few years and into especially the academics background and then how you transition upward into Nvidia.
Sure. So, life is a journey in a sense, and many things they happen by accident. So, on university, when I was still in Poland, we've been toying with this idea with my colleague to start a business focusing on finding tenders. I used to live in this large metropolitan area and with a lot of different cities, everyone with a different tender process. So this is how I started looking at the problem of information retrieval. That bit didn't work out, but on the back of it, at some point of time, I've submitted an application for funding of a PhD focused on information retrieval, so process of finding information, not necessarily in the internet, but funnily enough, despite the fact that statistically I didn't have very high chances, someone liked it. That particular application was rejected, but one of the reviewers suggested that I submit it to a different funding body, and that was accepted. And funnily enough, this is how I started doing my PhD, focused on finding information. I specialized in the process of supporting software engineers in software development process. So many of you most likely heard about Visual Studio, the programming interface from Microsoft, and right now Microsoft has this thing called Codex. So effectively, my PhD was focused on building something like that. Obviously, not with neural networks, but that wasn't the time for neural networks. With much more traditional approaches, but effectively we've been doing that. We've been trying to crawl various online code repositories and inline provide code recommendation that would go beyond what was then IntelliSense.
And when was this?
Oh, when was it? I think I started my PhD in what was it, 2011? Yes. So definitely a time before neural networks were understood, but at that point of time, no one perceived them as something that can work particularly well, and computation didn't exist to to train anything meaningful. So during my PhD, I was dealing with much more conventional algorithms, latent Dirichlet allocation, and also spent a lot of time looking at human behavior of search. So opportunistic programming, so how people actually formulate the search terms. So that's that. And funnily enough, when I was finishing my PhD, even before I finished, it turned out, because I used to do it in the Midlands, that nearby Jaguar Land Rover was just kicking off a part of the research department focusing on telematics, so connected car, and they needed people that understand machine learning. And I had a conversation that sounded interesting. So right after submitting my reviews to PhD, even before the defense of the thesis itself, I think I moved to Jaguar Land Rover Research, and then we've been doing a lot of different things. For those that are interested, just go to YouTube and type self-learning car Jaguar Land Rover. That was a project that I helped to shape. I wasn't working on it myself. It was a fairly large group, but that was one of the bigger things that I was focusing on, and rollout of telematics. And from there, it was just a fairly organic journey. Part of those projects involved neural networks. Coincidentally, it wasn't like a super aware life decision. At that point of time, it wasn't obvious that neural networks will actually work as well as they will. But we've looked at Andrew Ng's and Baidu's work on automatic speech recognition. This is something that was like needed. Automatic speech recognition in the car is complicated. You have a lot of background noise. So we've looked at that. We've started to look at reproducing some of that work, and this is how I, beyond just traditional machine learning background, created a bit of background in automotive. And it so happened that Nvidia recruiter was searching for people. He noticed the profile on LinkedIn, reached out, and after I don't know how many conversations, and I think the process like took 9 months, because it wasn't that I've applied and went for a formal interview process immediately. Like there was a bit of a back and forth. I joined Nvidia in 2017 and started to help with, at that time, predominantly also automotive. So working a lot with OEMs, so car manufacturers and tier one suppliers, predominantly focusing on perception for the self-driving car. I've been trying to help them define the process of training perception algorithms, which was at that point of time super difficult. Like you have to appreciate that in 2017, a lot of things that we take for granted right now didn't work.
Yes.
So like humankind didn't know how to scale neural networks. We just didn't. And that works in many different ways. We didn't know how to make them deeper because they would explode and not converge. So for those of you that don't believe me, just look at some older papers. So for example, at what was the name of the first? I think in Inception, you'll notice that it has those like multiple losses. This one at the top, but then also some on the sides. That's kind of some tricks to stabilize the training process. And we definitely didn't know how to train well in data parallel way with large batch sizes. Not to mention that the tools didn't exist. This is like Horovod. That wasn't something that was available. And so there was quite a lot of work around that. Also, understanding of hardware just started to formulate, and we had to discover a lot of things that are obvious today. And that's the journey. So on the back of that, I've learned how to scale neural networks. So when natural language processing, like this new revolution started with GPT and BERT, it became obvious that unsupervised training has a chance of working, but for that we'll need very large models, very large data sets. I focus on that. And this is how I am right now where I am, a journey.
Basically, you were already trying to scale the models that existed in the days. It's just that the hardware didn't allow you.
No, like no one knew how to do it.
Yeah.
So that knowledge didn't exist. I very distinctively remember NeurIPS 2017 in December. I've attended that, and there was a workshop on AI at HPC scale. No one knew. There were people from Google, Facebook. No one knew how to scale those models. It wasn't obvious what to do when batch size exceeds a certain threshold. Very bad things happen to optimization if you do that. Jan LeCun is I think once said that friends don't allow friends to train with large batch sizes, that it's good for their mental health. And that was true at that point of time. Now, obviously, you train with extremely large batch sizes. But...
So it was definitely a good, like you started at the right time, since you already had quite a lot of experience in the field before it got so much hype, like in the past, since 2018, let's say.
It's you say luck, but it's always, luck is a big part of life, yes. But you always look at the decisions ahead of you, you look at them critically, and you try to make a good decision at that point of time. And those kind of changes that I've made seemed logical. They could have ended up being a mistake, but fortunately they weren't. But...
And did you really want to do a PhD, or was this just to work on the project you had in mind?
How many people do you know that just went straight out of university and know what does it even mean? Like what does it mean to do a PhD and then have an academic career? That's a super abstract thing. Maybe if you have parents and that are publishing for a living. But my father was a miner. My mother used to work on a railway, so I clearly didn't have that understanding. It sounded like a good idea at the time, and the fact that I managed to win, a pot of money to also pay for it and sustain me for a period of time helped a lot with the decision.
Mm. But did you already have an idea in mind of like right now, for example, in artificial intelligence, a lot of people think that a PhD might be required to get a good job, and so like they are just aiming for the
Sure.
title.
So think about it. Like you're an employer. Yes, you need to hire someone. You get 500 CVs. You need to choose somehow who you're going to interview.
Mm.
You cannot interview everyone. It's just not physically possible. You cannot even interview a large group of people because every person that you're going to interview, that's at least, I would say, 2-3 hours of work if you want to do it well. Prepare, do notes, think about it. So you really have to be, quite selective at the get-go, and you need to use some heuristics. And you get a CV. So what can you look? What can you look at? Evidence of, evidence that would suggest that that person can do their job.
Mm.
PhD can be one of them. And if you don't have a PhD and you're a young person, how else would you prove yourself? If achieved something, published a paper, contributed substantially to an open source project, and PhD is not strictly required, but you need to start somehow. And PhD is in a sense, an easy way because it's super prescribed. You go to the university, you follow a program, and typically, if you don't, make some mistakes of have a lot of bad luck, at the end of it, you'll have a PhD. You would have contributed in a bunch of projects. You have published a bunch of papers. It achieves something that you can then, through which you can describe your skills. If you have some other way of doing it, and there are people that do that, amazing. But gaining the same level of experience without going through like 4-year PhD program is sometimes challenging. But we did hire a group of amazing people into my broader team without PhDs because they kind of proved that they can do the work they need to be doing.
And when you say you hired, were you the one of the people making decisions, looking at the CV, or just looking at the profile and
Sure.
deciding?
So I hired either personally into my team, and prior to having a team that I have supported hiring. So I've interviewed and I made notes with the critical assessment of their capabilities.
In that case, may I ask, how are you assessing their capabilities first, before the interview, but also during the interview? For example, when you say that there
Sure.
are different ways of proving that you can do the work, the PhD is one way, but what would be the
Sure.
other ways that you've seen or that you are looking for?
Like the most obvious thing, but you'd be surprised how few people do it, is to actually read the job description. I'm not kidding you. Really, a lot of people will send a generic CV without any consideration to what is it that the employer is looking for. So reading the job description helps, and then taking the next step. And after reading the job description, tailoring your CV so that you're answering the questions via your CV that needs to be answered. So, okay, the employer said that they want to see evidence of me knowing certain technology. How about I include that information and not talk about something irrelevant?
Yeah.
So that is the secret sauce, really. Just reading the job description and showing a bit of empathy and trying to spend time in helping the person that might know nothing about the technology to read through the CV. In our case, we can spend a lot of technical time going through them, but in many organizations, you will have either a HR person or a, I don't know, broker that has nothing, that knows nothing about the technology. And they are just matching keywords. So if you don't do yourself a favor and actually read the job description and then include appropriate evidence, then you have no chance of going through that first filter.
Yeah. But then when you get through this first round, there's the second round of, for example, selecting like the best 10% or something. So if, for example, you have a lot of resume and CV that includes the skills you are looking for, is there any projects or academics level that are more interesting to others? Like, for example, is it fine if his experience is all into Kaggle, different Kaggle competitions, or are you looking for someone that built a startup or push something online?
So actually, And I think we'll talk about it later because we've talked about it earlier. But like, I at some point, and really we should spend some time about it. Like building AI systems is not it's not a trivial task, and they vary. I think I've referred to it as almost like building cars. There are no people that know how to build cars don't exist. That's just not possible. A car is a super complicated end-to-end system composed of countless different components, and you typically need a fairly large collection of specialists. So I don't think I have ever hired a person that knows machine learning AI. I am typically looking much narrower than that. And so a person that understands inference, a person that understands automatic speech recognition models, a person that understands to an extent natural language processing, a person that shows evidence of experience in deploying computer vision pipelines into production, a person that understands embedded systems. Kaggle is maybe an evidence of a person knowing to an extent traditional machine learning, because in Kaggle there are very rarely neural network-based competitions.
Most people really want to basically learn to do everything, so
That's not possible.
so be more generalist, but you would advise to rather focus on something which will maybe help you build a stronger portfolio for a very specific job.
It's not possible to know everything. It's just not. Like there exists this small subset of people that seem to have superhuman capability and consume information much faster than everyone else, and those people can know a bit more.
Yeah.
But it's just not possible. I'm trying to focus right now on two things, namely scaling of natural language processing pipelines and inference, so optimizing models for production. And I don't claim to be keeping up to date with the literature, because between reading I have to do also other things like help customers resolve issues, and so it's just physically not possible.
Yeah.
Obviously, some high level of general knowledge helps.
What is it like, for example, if someone gets through the first steps and starts the actual interviews? What does it look like? How many interviews, or what the not really the questions, but what is the shape of the interview and the format of the interviews?
Sure. So every organization, and more frequently even a group in the organization, will have their own way depending on their own needs and capabilities and bandwidth. So I cannot comment for Nvidia. I cannot even comment for my broader team. I can tell you how I do it.
Yeah.
Yes. So I tend to be quite empathic, and I start by reading the CV. Yes. And in the same way as I would like them to read the job description, I read the CV, and I typically just ask them about the things that they have written in the CV and make sure that they actually understand them, because what's the point of asking them about something that is not listed there? I would hope that CV has enough knowledge there already so that I believe that person can do the job, and I'll just focus typically on that. And if there are certain gaps between the CV and what I need them to do, I'll also be focusing on that. So if they would have read the job description and prepared to the interview by looking at all of the things listed there, they should be able to have a very meaningful conversation with me.
So an ideal preparation for such an interview would be to, as you said, look at the
read the job description.
Yeah.
Yes.
Read the description and understand it, but also look further into the bits of the description that you are not sure you are skilled about.
So let's say I'm looking for someone that understands, I don't know, inference process, and I'm writing that I need someone that will be, among many things, that will be supporting customers in quantization hour training. It's a huge chance that someone will ask me about quantization hour training. It might be a simple thing, and I might spend 5 minutes reading about it and understand it very well. And in fact, it is. But if I don't even devote 2 minutes to even on high level understand it, it shows that, it's also to some extent that I don't care. Sure.
I've seen that you were a deep learning architect at Nvidia.
That's
So
correct.
could you explain a bit what is a deep learning architect, and especially what is it in your case? Because I assume, as with
Sure.
most title, it may vary depending on the
That,
company and.
that's correct. So at Nvidia, I think that means actually something quite different to what it means in many other companies. So solution architects are part of pre-sales organizations. So their goal is to support customers in adoption of our technology. But Nvidia tends to focus on things that are difficult. That's almost like one of the key principles that drive the selection of what technologies NVIDIA is and is not developing. As a consequence, solution architects tend to be, very specialized in like quite narrow field. So, but the role is on high level quite straightforward, at least to explain. We effectively have, in contrast to research scientists that understand, one topic, one very narrow topic very well. Our role is to understand substantially broader set of topics, also relatively well, but obviously nowhere near as well as individual researchers, and help to bring all of those things together. Because as I mentioned, building of AI applications is almost like designing and manufacturing cars. A lot of pieces that need
Yeah.
to come together, and an architect is a person that can grasp those pieces, maybe not understand each and every component to its finest detail, but grasp those pieces together and bring them into a holistic end-to-end working solution.
And what pieces are you working on? You mentioned that you were mainly working
Sure.
on scaling, but are there
Yeah.
any other pieces
Sure.
that you touch?
So that's my core area of competence. So, a lot of people throughout Europe, if they need to know something about that piece, they would reach out to me, and I have other colleagues that are specialized in other things as well, that are my go-to support people. For example, a colleague of mine, Miriam, she specializes in Riva, which is our platform for conversational AI. I have quite a bit of respect for Dai, for his systems knowledge, and so on and so forth. So I specialize in that, but I support a broad range of activities of customers, because especially when customers are just starting the journey, a lot of things I can cover with my knowledge. So, stuff associated with data preparation, labeling, establishing first pipelines, development of first metrics, kicking off first jobs, monitoring their performance, doing error analysis, measuring efficiency with which they execute, first deployment into what will become a production system. So the end-to-end process, we try to support customers. Some of them know all of that already, and then they have very specific questions. And then we just work with engineering to fix bugs that might be in the software. Some of them don't, and they require more holistic support.
So you mentioned customers. I assume you are part of a team at Nvidia that helps with other companies asking for Nvidia's help using their
That's
product,
correct. Yeah.
or
Our mission is to support the broader community in adoption of AI technologies. Maybe the word customer is a bit misleading, because NVIDIA sells through partners, and you can buy our GPUs from AWS or Hewlett Packard or Dell, Micro, etc. But yes, our mission is to make sure that the broad community can and adopts our technologies. And yes, that includes GPUs, but like we are more of a software engineering company than a hardware manufacturer. The entire deep learning stack is filled with NVIDIA software, from cuDNN through countless PyTorch libraries. We are a major contributor to PyTorch, TensorFlow, and Triton Inference Server, TensorRT, and many, many others.
Could you go over a bit more details into one specific recent project that you've had or had to help with?
We have an upcoming conference called the GTC. It will be on the 20th, and there will be two projects that I've been supporting recently. I will not be able to go beyond what is already published on the website. I want to leave the surprise to the people that will actually be with me presenting on the event, but like we have two talks, one with Jaguar Rover and another one with Deutsche Bank. And in both cases, I was supporting them in development of natural language processing capability for different use cases, totally different use cases, totally different sectors, but the same technology stack and same problems. I have a problem to solve. That problem is important to me. How do I create a training data set that is sufficiently big to allow us to achieve our goals? How do I scale the training process? Once I've succeeded and I've reached my metrics, how do I now provide this user to a large group of people and solve some fairly standard yet not trivial to solve problems like GPU utilization, making sure that it's high, reaching latency targets when executing those models, scaling those models. So what if the demand from the users is bumpy? How do I deploy dynamically a couple additional GPUs and then scale down? All of those problems are obviously solvable, but they require a lot of tools and a lot of knowledge. So we help and point them into the right direction.
And for example, you said that the kind of the same technology were applied very differently on the two projects. So what are the similar challenges on both projects, but on all your projects? Is there a recurrent challenge or something that right now you know how to do, but is like complicated for other people to do and thus need your help?
So most of the problems, when you look at them from like miles away, they seem simple. What is really difficult is the fact that life does not work like that. You don't get one thing. Instead, you get every single day a medium scale problem to solve. There's just a lot of them. And we want to label data. How much data do we need? Okay, we need to establish that. And how exactly do we label? Let's define that. Okay, that's a lot of data to label. I cannot do it in one evening. So who exactly will label the data? Okay, I'm not labeling the data. I need to explain how exactly I want to label to all of those people that I just hired. Okay, they've labeled some data. How do I know that they've labeled it in the way that is appropriate? Yes. Okay, I cannot do all of that quality analysis. I need to, maybe get a dedicated person to oversee that process. And you go through the pipeline, and all of those problems in itself are not like rocket science, but all of them need to be solved. And some of them actually are surprisingly tricky.
And since you mentioned the working with NLP, mainly NLP tasks, you are also working with very large models and very large data set as well. So may I ask how the different, not customers, but the different people that are working with you are dealing with these very large either model and data sets? So like a lot of compute as well as a lot of space required. So what's your typical solution for that, or just like how do you process that?
So 2 years ago, this would be a very difficult conversation, but today tools just exist. Like you can go to your favorite search engine and search for, say, Nemo Megatron, and that's a tool with which you can largely change the language code. And I don't know, you want to build a model for Polish, you change the language code, it will download a piled data set, you then click, and if you have compute, that will train you a fairly decent language model of almost any size you want. I think we've published hyperparameters for models up to 175 billion parameters. And it will scale perfectly as long as you have the right hardware. So by perfectly, I mean linearly. So that's not a problem. We have published reference designs for how to build systems that will scale linearly. We have this thing called superpod reference architectures, and many people are reusing those also for their own system design. So we know exactly how to train and prompt tune or adapter fine tune or those models. The literature exists. Today, this is not as big of a challenge as you might think. And for an individual the amount of hardware needed can be scary if you think about, oh, how much my car costs. But then, a typical large company, sometimes in a canteen will spend same amount of money on sandwiches in a year than what it takes to train those models and electricity. So those are not as challenging problems as you might think. And there are many startups that have set up either in-house or via some partners large training systems that they use for training of those jobs.
So compared to the past, the current challenge is mainly to find which tool to use and how to use them in a way that they would be like cost effective rather than developing something yourself.
There are a lot of organizations that are developing tools themselves, but if you don't want to develop tools for training large language models, you don't have to. You just go to NEMO website, you download the code assets, and you download the container, Docker container that packages everything that you need, including the software. You configure a single YAML file to point it to where the data is located and choose the size you want. Actually, preparing the data is always difficult. It's not as easy. Yes, you can download like Pile and train on that, but that model will not have necessarily all the properties you want. The system's hardware exists for training of those models. It's not that difficult. One of the big challenge is like people. There aren't that many people that actually know that those tools exist, let alone know how to use them or have any hands-on experience using them. But that's just a function of all of this being very new. Bear in mind, I think BERT paper, and that's not a large language model, that was published in 2018? No, end of 2019, where we've showed curves demonstrating that larger NLP architectures trained with larger models on larger data sets improve in sample efficiency. So all of that is super new.
So what would you, well, I assume this is one of the things that you will talk in the two events at GTC coming, so people can learn more about how to scale NLP models and just to deploy them.
And we'll have dedicated talks devoted to that as well. So I think those talks are, the two talks that I've mentioned are predominantly focused on what specifically Deutsche Bank and Jaguar Land Rover has done. But we will have dedicated talks also focusing on large language models from various different perspectives, from hardware to software. We have this thing called LLM service, which is like hosted large language model. So there will be all sorts.
Yeah, perfect. And so if for the audience, if you are interested in learning more about what we've just discussed, there's the talks will be in the description below. So it's as Adam said, it's completely free and it's during the GTC event coming. So just to go a bit more into your Nvidia work, I would just like to ask a very basic question, that is, what is your day-to-day life at Nvidia? What are you doing on a regular basis?
Our job is quite flexible, yes, and really changes with not only the technology landscape, but also with where our customers are. So when I've joined in 2017, my job was dramatically different to what it is right now. Yes. So in 2017, there wasn't that much of an adoption of deep neural networks. We had some selected customers that we've been supporting on a day-to-day basis. We've been supporting a lot of academic and business events, yes, preparing talks and doing evangelization. And now it's dramatically different. Right now, a lot of those early customers matured. We have like very large inference deployments. So I personally have a couple customers that will have multiple thousands of instances of Triton inference server. We have regular engineering calls during which they ask questions, ask for features, raise bugs, and I have to work with product management to prioritize and resolve them. We definitely have now less of a presence on those like business-focused AI events because there is less need to do that. And I don't think I have a super strict daily routine. Yes, I have a schedule of engineering calls with a fairly large number of organizations, like every week, maybe every 2 weeks, maybe every month, depending on the pace of their progress. I'll dial in, we'd have a conversation about progress they made, issues, challenges, maybe bugs. I would then try to resolve some myself. I would then pass some on to engineering. I support development of proposals, just day-to-day conversations with customers, and answering deeply technical questions around details. So things such as sizing, scaling. How many GPUs do we need to train a model of this size on this data set? Or how many do we need to be able to work with a team of 6 to do, I don't know, prompt learning or adapter tuning on working towards this problem. And then it changes throughout the year as well. So closer to events like GTC, we focus slightly more on the content. Sometimes prior to GTC, we support development of demos. We have some customers that we work very closely with, lighthouse account customers that we support more intensively. So for example, I just published a paper with a company called InstaDeep on nucleotide transformers. So I know very little about biology, admittedly, but I do know how to force neural networks to scale well. So I was hands-on helping them to make sure that their very large language model works very well on proteins. So there isn't a single recipe that I follow on a day-to-day basis.
Yeah, super interesting. It seems like for all the interviews that I had recently with people working at Nvidia, you have a very broad range of projects that you can participate in and learn from. So it seems really cool.
Yeah, Nvidia is trying through their culture to be very agile and quickly adapt to this admittedly insane technological landscape.
Yeah. And would you say that this technology is more insane now than it was like in 2018 when you first joined Nvidia?
Dramatically more. So I have like almost every day or every year I say the same thing. I've never seen such a fast rate of progress.
Yeah,
it's unbelievable. Like if you would take, I don't know, what was published right now on those instruction-tuned models and take it to an academic conference 2 or 3 years ago, they would refer you to a mental institution. Like, I don't think anyone would have believed that in such a short period of time, those models would exhibit those types of behavior, especially that in most cases, we are not necessarily explicitly training them to exhibit those behaviors. Those are emergent features. Most of those models are just trained to predict the next token.
Yeah, it's indeed crazy. And how do you keep up with this rate of progress?
I don't think I do. Yeah, so I have my day-to-day job. I do a bit of reading based on. We have an amazing research team, and we have internal email and other newsletters where people just raise the most important stuff. So they do an amazing job at filtering.
Oh, nice.
But I don't like, it's not possible. So not even across entire AI, but even right now within natural language processing, it's just borderline impossible to keep up with everything. And you have to learn to let go and focus on what is it that you're doing, what are the problems that you have in front of you, solve them, and try to add value like that.
So as the field is maturing like this, or just getting crazier, would you say that you have to be more and more specific on what you're doing compared to 5 or 6 years ago?
Oh, definitely. So we had that conversation with some of my colleagues. I don't remember exactly when, doesn't matter, I guess. So when I joined NVIDIA in 2017, it was somehow possible, yet already challenging, for me to grasp everything AI NVIDIA. Right now, it's just not practical, not possible.
And
it's too much.
Would you say that it's more challenging now compared to then, when you know, for example, it's definitely different challenges. Back then, you had to learn a lot about everything, basically, or like it was difficult to know what to learn about just because you have it's not as broad, so you can allow yourself to learn about a bit everything, compared to
Mhm.
versus now you have to learn a lot about a very specific thing. And as I said, the challenges are very different. Would you say that it's harder now or harder then with the different challenges and different things to do?
I'm not sure harder. At that point of time, it was also quite hard because
Yeah.
a lot of things were super non-obvious. And, and right now, there is just a lot of very good quality research and engineering coming out. So just you have to learn to let go. Just it's okay. You cannot know everything. I at some point I was trying to keep up with both natural language processing and computer vision research, but I think I had to let go of computer vision. I know obviously that transformer architectures are very popular. On occasion, I'll skim through a paper to make sure that I more or less know how to understand them. But if you were, and I look at multimodal architectures now a lot, so that helps me uh, be somehow up to speed and unsupervised models. But if you were to ask me what is right now the best architecture for, I don't know, object detection on MS Cooke, I don't know.
Yeah, you can ask ChatGPT, so that's
Yeah, I can
you
go to
don't have to
papers
know.
with code. Doesn't matter. I don't know from the top of my head. You
Yeah,
have to let go. There's too much.
yeah, it's even this thing is even stronger now. When Google first came up, it's
Hmm.
already a different mindset of instead of trying to gather knowledge in your own mind, you just need to understand how to find the knowledge because
Sure.
Google has everything accessible from your fingertips. But now it's even more towards that way of just basically you need to know how to type to ChatGPT or whatever machine learning model that will give you the answer if it's not hallucinating, but that's another thing. But like it's it's what I think is that it's very dangerous for our own memory just because we don't have to know as many things, nearly as many things as we did in the past. And so maybe our memory will just atrophy or something, but that's
No, it's still useful to memorize stuff. It's just you cannot just rely on search. Your expertise come from the fact that you can bring together facts and combine them together to
mm.
create new insights.
For your current project, which is something that I think a lot of people are interested in too,
Hmm.
scaling and natural language processing.
Sure.
What is your well? This question has two folds. The first one is what is your favorite tools to use, and the second one is what is your tech stack, programming language, and other like internal tools you are using.
So the tools that we're using are open sources, and I use almost exclusively those. So on a day-to-day basis, when it comes to NLP, and I do other stuff as well, don't get me wrong. We use Nemo. Uh, uh, I use Nemo for both natural language processing, but I work with quite a lot also in like this broader conversational AI. So I do support quite a few customers with automatic speech recognition as well, and less so in text to speech. And Nemo provides foundations for those models as well. For users that don't want to be exposed to the low level elements of implementations of Nemo, we also have this thing called TAO, which stands for um, Train, Adapt, Optimize, which effectively helps people with less of model knowledge to just fine tune models on their own data sets. Um, I, so I use Nemo and historically Megatron LM also for a lot of natural language processing work. Prior to the generative models, um, where we've been working with smaller BERT-like architectures, those were typically just standalone models that you can still find on our deep learning examples Git repository. On inference front, I predominantly, if not exclusively, work with Triton Inference Server, which is an open source inference server used by many, used by Microsoft, integrated in Teams, Office, used by American Express and many other organizations. And it has a backend called Faster Transformer through which which is still quite early, but it already works quite well in my opinion. Through which you can integrate even the largest of language models for serving. So even if you have a model that doesn't fit into a GPU, faster transformer has a tensor and pipeline parallel implementations. You can slice the model in half, either vertically or horizontally, and serve it like that. But if it's so huge that it doesn't fit into however many GPUs you have in a server, say 8, it also supports like multi-node serving, and it has a lot of tricks up its sleeve around just optimizing autoregressive inference, because models like GPT are autoregressive, meaning that you generate one token at a time and then you do a lot of forward passes. So there's a need to do a bit of trickery so that you don't compute the same things over and over again. So that's kind of that. I work mostly with PyTorch. That's just because the tools are available for PyTorch. And I also work with TensorRT quite a bit. TensorRT is a tool that we also provide to the community that takes a neural network that was trained in, say, PyTorch, or that was exported into Onyx, and it optimizes it for deployment to a specific GPU. So it does things such as, I don't know, fusion of layers of kernels. It does post-training quantization and quite a few other things. And that list, I work a lot with Riva. Riva is our stack for conversational AI, so provides pipelines for automatic speech recognition, text-to-speech, and now also has an early version of chatbot maker and all of the satellite utilities around the technologies that I just mentioned.
Are you surprised by the fact that open source technologies are so powerful? Like compared to proprietary technologies, is it something that is, like, to me, this is something like that is kind of mind-blowing, that everyone can access that and even right now build companies and make profit off of tools that were developed openly for everyone.
I'm not sure whether I have a very strong opinion or ever thought about this problem in a lot of detail. Definitely for technologies that have a big community, this is a blessing, yes.
Yeah.
But at the same time, there are countless open source projects that are just maintained by one person, and they have no chance of competing with a dedicated enterprise solution.
Yeah, I was asking that because right now we are in a world where, for example, there could be ChatGPT that is completely owned and built by a specific company, and so you have to pay, and you cannot really do, well, you can do a lot with it, but you cannot really work with its inner working and modify it. Whereas, for example, there's the Stability AI with open source work, and like I feel like just before Stable Diffusion, the most open source projects were kind of not a pale copy, but were under the proprietary technologies most times. And I'm feeling like there's a turnaround now where open source technologies is becoming closer and closer to companies, or even more powerful now.
Is that true? Like, there are plenty of Apache Foundations projects that are just at the foundation of the internet.
Yeah, of
you know
course,
that Linux is open source, yes?
Yeah.
So they always played a role, but there is always also a role for commercial products. So open source is not necessarily cheap, you know that.
No, of course.
Let's say you have a small company, you take an open source project and something doesn't work, and your only person that understands that project cannot solve it. What do? You ask politely to the community, and they maybe do or do not help you. That's not a way to do business. So there is obviously value for many other companies to provide commercial services around those open source projects, provide alternatives. Even Nvidia, we have this thing called Nvidia AI Enterprise, through which we provide support for people that want it to all of the open source tools. Like, if you find a bug in PyTorch, we'll fix it, yes, for you. And so there is a value in those. And if you ever would, like, I participated in deployment of production systems. So if stuff goes wrong, you want to fix it.
And I just wanted, as my similar to my other questions, what is the biggest challenge or the recurrent challenge in just deploying models? Is it something that is more
Okay.
difficult than other stuff?
So you never deploy models. You deploy pipelines.
Yeah.
Like I don't think I've ever participated in a project where you deployed a model. The challenge is that you deploy really a lot of different things that need to work together and that all have different properties. So I don't know, in computer vision, let's say you get a video stream. First thing you have to do is to decode the stream. And decoding in itself is super non-trivial. You have to think how you do it. If you just do it with some random library on a CPU, that will just be maxing out all of the servers, and you'll be not making much money. But you know, if you choose the right codec, Nvidia GPUs have hardware acceleration for video decoding, and suddenly that becomes free. But then next step, you want to do some pre-processing. Let's say you've used Nvidia GPU for decoding. Yes, so you want to use a library that does something, then I don't know, trims the image, doesn't really matter. But you choose to use a CPU library because your team knows it. That has implications. You have to make a memory copy from the GPU memory over PCI Express to the host, and you're putting load. So so in most day-to-day life, you don't deploy a model, but a quite complicated multi-stage pipeline that typically is composed of substantially more than one neural network.
Yeah.
Even in computer vision, so you might first of all do, I don't know, identification of regions of interest, and classify initially those regions of interest, and then pass on those regions to individual in neural networks that do different things. I don't know. In the shop setting, theft detection, vandalism detection, or analytics, you want to have a shared decode, because for every one of those use cases, you don't want to decode the video stream over and over again. And then you do like common detection of locations and maybe a couple other neural networks. And then you have another neural network that does tracking. And then you might neural network plus a classical tracking algorithm. Classical tracking algorithm because it's cheap, and neural network because if someone goes to the toilet, he wants to be able to re-identify them. So for re-identification, you'll have a second neural network. So suddenly what was just, oh, I'll deploy whatever, mask RCNN, ended up in being this quite a big monstrosity of components. And all of them need to work, all of them need to scale. In video analytics, it's easy because the workload is like clockwork, 30 frames per second. 30 frames per second. Yes, but in many cases it's not. So your customers come in waves at Christmas, and then they don't come at all on New Year's Eve, and you don't want to be paying for the hardware.
Yeah.
So it's such a multi-dimensional problem. Inference requires quite a lot of work, quite a lot of people with quite a lot of different expertise.
So the main challenges come with the complexity of the solution, as well as the complexity of the Prussian and randomness behind it.
It's just life. Like life is never that easy. Like even things that seem super trivial when you look at them from 100 miles away, when you start digging into the detail, have a level of complexity. That level of complexity might not be necessarily high. Like neither of the things that I just mentioned is rocket science, but it's just a lot of it. And you have to systematically tackle every one of those problems. And that requires a bit of patience, a bit of character sometimes, and you know, especially if you have a younger team without experience of doing it earlier, quite a bit of time. And this is kind of the support we provide. Like, we have a very capable team that has done those things quite a few times, and this is the type of guidance we give them.
So my follow-up question was about the two talks we discussed that you will be giving at GTC.
Sure.
And so, is there anything else you wanted to mention about those talks, or just at least maybe summarize why should people tune in to those two specific talks that you are giving at GTC?
So if you emphasize with what I just said, yes, around just day-to-day complexity of solving problems, those talks will be great for you, because
Yeah.
you'll hear two different groups that are solving two dramatically different problems talk about more or less the same pain points of getting the first pipeline up and running, writing KPIs, and you'll get their point of view of how to solve those problems, and hopefully it will help you plan your projects a bit better, and give you some ideas on what things to put in place and in which order, because I think both of those talks are organized chronologically, in a sense that they just go through the journey from the very beginning to the very end, highlighting all of the key things that caught them by surprise. They also go into motivation in quite a bit of detail. So why did those particular groups decided to embark on that journey? And that's also something that might help you, maybe if you're not in an engineering role, but more of a in a management to help you think more systematically about what is it that is possible with natural language processing.
So very, we should expect very applicable tips from real world examples, basically.
Yeah, people will obviously have different experiences, but yes. Yeah.
Awesome. Well, thank you very much for your time and for all the very valuable insights. It was really interesting, and I learned a lot just in this past hour or so. So thank you very much for your time again, and I was glad to have you on this interview.
Thank you, Candy, and have a great day.
You too.